This video is Unit 4 Test Review Part 2. This is at the top it has the it's teak. Which of the following sets of numbers can be the lengths of the sides of a triangle? So we'll just write yes or no, but how do we know? Okay, we're gonna pick a number. I like to pick the biggest. And I need to make sure that it is, I always know that it's definitely bigger than 8 minus 3, the two smaller ones subtracted. I know that's always true. So really I just need to make sure that the 20 is less than the two other sides added together. 8 plus 3, I was writing 8 plus 11 because 8 plus 3 is 11. So that's 11. So 20 is not greater or less, not less than 11. So basically the two smaller sides have to be greater than the third side, than the biggest side. Here I already know that 4 plus 4 equals 8. So that one's a no, but let's write out how we know that. I picked the biggest, 8, and it has to be less than 4 plus 4. And 4 minus 4, but I already know that because those are smaller numbers anyway. So 0 is less than 8 is less than 8. No, it's equal. So that would be a no. Well, do we have one? Let's see. This is my biggest. I already know that it's going to be greater than the two smaller ones subtracted. 8.1 minus 6.3, we already know it's going to be less than that. So is it less than if you add 8.1 plus 6.3? 8, 9, 10, 11, 12, 13, 14.4. So yes, it is. 12 is less than the sum of the two smaller sides. The biggest side is less than the sum of the two smaller sides. If you chose a different size between the biggest, you would want to make sure you checked both, the adding and the subtracting. That's all. It works for any side, okay? I like to make sure, I don't know, that's my pattern, is to check just the big one. Okay, if the measures of two sides of a triangle are 7 and 20, what is the range for the measure of the third side? Well, this is when we subtract. We have 20 minus 7. You always want to have a positive number, so take the bigger one minus the smaller one. And then 20 plus 7. So your range is 20 minus 7 is 13, is less than x, is less than 27. So this is the range. Can it be 13? No. Can it be 27? No. But anywhere between those two numbers, our third side can be. Okay, if two sides have the length of 6 and 13, which of the following lengths could be the third side? Well, again, we'll subtract them. 13 minus 6 is less than the third side, x or t or whatever letter you want to call it, and 13 plus 6. So 13 minus 6 is 7, is less than x, is less than 19. Okay, so 1 is not between there, so that's not a good one. 21 is not between 7 and 19. 15 is, and 6 is not. I'm just going to write on here, if I had a choice E and it was a 7, that would be a no. And if I had a choice F and it said 19, that would be a no. And on the test, it might say which could not be. Okay, so then you would cross off all the ones that could be and go with the one that can't, okay? So just be careful on tests when they might say which is not. Any questions on those? Okay, again, I'm going to keep going because I'm only on page 3 and 6 pages. Oh, this one only has 2 problems. Okay, we got the teak. If CD is the perpendicular bisector of AB, so we know we have a right angle, and we also know that these 2 segments are equal. We don't know if CM is equal to CD. We don't know that because it doesn't say AB is the perpendicular bisector. We only know that CD divided AB in half. So we do know that CD is perpendicular to AB, I'm sorry. We know that. And we also know that AM is equal to MB because it bisected. Draw an example of an angle bisector. Okay, so let's draw an angle and cut it right through the middle. And there we have our 2 congruent angles. We also know that if there is a point on the angle bisector, that it's equidistant to the sides. So if I had a perpendicular line like this and a perpendicular line like this, that those would have to be equal. Just pointing out which actually is the angle bisector in this picture. Any questions on that? We also know that CA, up here on the perpendicular bisector, this segment would be equal to that segment if it's a perpendicular bisector. Because any point on a perpendicular bisector is equidistant to the endpoints of the segment. So we also know that CA is equal to CB. And DA is equal to DB. And later on, we'll learn that that would be either a kite or a rhombus. Okay, next page. The teak. If GT is the median, that means these are equal. Find FE if TE is 8. So if TE is 8, TF is also 8 because that's a median. And that means the whole thing is 16. So FE is the whole thing, and it would be 16. And I promise you, if this was a multiple choice, 8 would be one of the answers, so you have to be really careful and look at what is being asked at the question. Okay, number 14. If IN and KL are medians, find LJ if IJ is 6. So this whole thing is 6. That means LJ and IL are equal. So divide it by 2, each part would be 3. We also know here that this is a centroid. And if we knew X, this would be 2X on the other side. That was just like extra stuff that I added there just now. Oh, wow, we're getting done. It's 9:32, okay.